Now we're going to look at the step in hypothesis testing where you choose a test statistic. And in this short video, we'll give you some general guidelines to help you with this process. So the test statistic is the statistic. So remember, that's a number we can calculate from a sample that we are going to be able to simulate the distribution of to help us decide between the two hypotheses. And sometimes we'll actually be able to calculate the theoretical distribution of the test statistic without simulation, but at least we need to be able to simulate it if we can't do it theoretically. So what to think about before choosing the statistic is to think about what values of the statistic would make you lean towards the null hypothesis versus what values would make you lean towards the alternative. And in particular, we're going to use the alternative hypothesis as a guideline for choosing our test statistic. Preferably, you want to choose a test statistic such that either high values or low values would make you lean towards the alternative, but not both. So this is just a convention in our class. We are going to replace what you may have seen in past statistics classes where you do what's called a two-tailed test and you look high and low. Instead, we are going to replace that by defining our test statistic in terms of an absolute value in that case. So we just need to look in one direction. This is just a simplification for our purposes. If you're used to two-tailed tests, you're fine doing those as well. But for our purposes in the class, I want to make this as intuitive as possible. So we're going to try to avoid looking on both ends, and we're just going to be looking in one. And so I'm going to show you an example how we can set up a test statistic so that that will be the case. Suppose I am interested in whether or not a coin is fair. So we are going to toss the coin 500 times. And our null is that the coin is fair. In our first example here, our alternative is no, it's biased towards heads. And in our second example, our alternative is no, it's not. So take a minute, and in both of these cases, think if you can come up with possible test statistics we could use for these two different scenarios. Okay, in either scenario, I can count, say, the number of heads. I could have also counted the number of tails, doesn't matter. But I'm just going to say, let's count the number of heads that we get out of 500 as a starting point. And in that case, for A, large values of the number of heads or the percent of heads will suggest bias towards heads, right? It would be in favor of the alternative. So that means I can basically use, for example, the percent of heads or the number of heads or the percent of heads minus 50 or the number of heads minus 250. All of these for large values of any of these test statistics, they will be suggesting the alternative, right? So those are great ones to use. Okay, now let's look at this next case. The coin is fair and the alternative is no, it's not. Now, I could still use number of heads, percent of heads, but the problem now is that I want to account for whether or not it's too high or too low. And I want to account for that all in one test statistic. So very large or very small values suggest not fair. And in that case, the distance between, for example, the percent of heads and what I would expect, 50%, would be useful as my test statistic. So I could do the absolute value of the percent of heads minus 50%, or the absolute value of the number of heads minus 250, because I would expect 250 if it was fair. Either of those are great test statistics, because in that case, once I've taken the absolute value, large values of these are going to be suggesting the alternative. So large values are in favor of the alternative, and that's what I want. I want to just be able to look in one direction for my analysis of this process. So these would be possible test statistics. I think the key takeaway is if a direction is implied, then you can just use either straight up proportions or counts or differences without needing an absolute value. If there's no direction implied, if we're looking both ways, then you're going to need an absolute value somewhere in your test statistic. So I'm going to summarize this here. If the alternative is the null is wrong, so there's no direction associated, then if you're comparing counts or means, you can use absolute value of difference. If you're comparing proportions, you can use the total variation distance. So in our video where we looked at the Alameda jury panel example, we showed this statistic, and you notice it did involve taking an absolute value of the differences and then summing them. If your alternative specifies a direction, for example, fewer than or greater than, you can use just a count or a proportion or an average or a difference. And you'll just need to keep track of which end of the distribution favors the alternative. So that's the direction you'll be looking when you're calculating your p-value and conducting the test.